All right, so we are starting our new module today. And just to let you know, module 6 here, which is on inequalities, this will be our last new module for this semester. We don't have a lot of time really left in this semester. We have 3 more days this week, 4.5 days next week, because Friday next week is a minimum day as we go into Thanksgiving break. And then when we come back from Thanksgiving, there's only 3 weeks total. And part of that includes final exams, because we take the final exams right up until we go off for winter break. So module 6 here will be our last module. We also have to get a district benchmark in before we review for the final exam. And we have some of that time will be spent reviewing, because the final exam will cover from August all the way through this module that we're doing now. So anything we've done in first semester is fair game to the final exam. So really, with winter break, with Thanksgiving break and then winter break, we do not have a lot of time left in this particular semester. So we are coming down to the end now. All right, so hopefully you've already put your first and last name on your notebook, along with your period number. And then if we go inside to that table of contents page, we are going to be starting those notes, solving one-step inequalities today. So might as well go and put 11/12 there, because that's today's date, and we are going to be starting that. But stay on that page, because we do need to add in our essential questions for this unit. The first question: how do solutions of inequalities differ from the solution to an equation? How do the solutions of inequalities differ from the solution to an equation? And the second question: how can writing and solving inequalities help you solve problems in the real world? How can writing and solving inequalities help you solve problems in the real world? All right, now we need to go to page 7 so we can start the activity, or start the notes. All right, so we're starting off with solving one-step inequalities. So what is the difference in graphing an equality versus an inequality? So this digs right into one of those essential questions there, understanding the difference in how the solutions are graphed. Now, when we say x equals 5, if I draw a number line here, and my number line does not have to include 0. I usually just put 3 markings with the number I'm talking about in the middle. So I would label this one 4, 5, 6. And when we graph an inequality, we draw a point on the solution. So I'm going to add those words here. You draw a point on the solution. So in this case, if x equals 5, I go to 5 on the number line and I just draw in that point. That would be the graph for x equals 5. Now, for x is greater than or equal to 5, the number line itself actually looks very similar. I'm still going to put my 3, have my 4, my 5, and my 6. But there's a couple different decisions that have to be made here. You have to decide open circle or closed circle. Then you have to decide which direction to shade. And what we're talking about, open circle, closed circle, we're going to add a little here. So open circle, the number is not included in the answer. And then closed circle, the number is included in the answer. So when I go back to x is greater than or equal to 5, I'll tell you greater than or equal to, that's going to be a closed circle, and we'll talk about which ones are open circle and which ones are closed circle in a minute. So closed circle means I go to 5, I draw a point. So right now, the two graphs look the same. I drew a point at 5. But this one says not only do I want to include 5, but I want to include every number larger than 5. So in this case, that means I have to shade to the right, because every number that is greater than 5 is to the right of 5 on the number line. So I have to shade in that number line, including the arrowhead. And the reason I have to shade in the arrowhead is because the number line doesn't end where I end drawing it on the paper. By shading the arrowhead, you're saying that not only does the 5 included, but every number beyond that 5 and beyond what is drawn on the number line. That number line keeps going on indefinitely to the right. So we're including every number that goes to the right there. So that would be the difference between graphing an inequality and graphing an equation. Equation, it's just one simple point. And inequality, there's decisions that we have to make, and we have to understand the symbols. Now, we're also going to need to know some words or phrases that will tell us these different symbols. So for greater than, which I'm showing you the symbols there, for greater than, some words or symbols, one phrase would be more than, exceeds, larger than. These are all words or phrases that tell us we would just be using our greater than symbol. Greater than or equal to, some words or phrases, at least, a minimum of, no less than, some words or phrases for less than, smaller than, obviously less than, fewer than, and then for less than or equal to, at most, no more than, not exceeding, a maximum of. Again, that's not necessarily an all-encompassing list, but these are the words or phrases you're going to see most when they're talking about inequality symbols. Now, for open circle, closed circle, The ones without the line under them, just the greater than and the less than, those are both open circles. So greater than would be an open circle when we are graphing, and less than would also be an open circle when we are graphing. And then greater than or equal to, less than or equal to, because the number is included, these would be closed circles. So we need to know which symbol gets an open circle, which symbol gets a closed circle. And then when it comes to the shading, if the variable is on the left-hand side, the inequality symbol will point the direction that you need to shade. So for these first ones, graph the solution set of each inequality. Well, I look at this is x is greater than -3. Greater than, we said, is an open circle. Greater than, the point of the inequality symbol is pointing to the right, so we're going to shade right, because that's where the numbers that are greater than -3 are. So when we draw our number line here, again, I'm only going to put 3 spots on this. So I'm going to have -4, -3, and -2. So open circle at -3, that means I'm going to draw an open circle to show, hey, do not include -3 in your answer. And I'm going to shade it to the right because every number to the right is also a solution. Question B, x is less than 5. Less than, we said, is also an open circle. This inequality symbol points to the left, so we are going to shade left. That's where all the numbers that'll be less than 5 will reside. So I draw my number line. Again, we already said that this is going to be an open circle at 5. And we're going to shade to the left. Those are all the numbers that are less than 5. C, x is less than or equal to -2. This time we have that or equal to part of the inequality. So this is going to be a closed circle. And I want the numbers that are less than or equal to -2, so we're going to shade left. So again, draw my number line. -3, -2, -1. This time I want a closed circle at -2 because it is part of the solution. And I'm going to shade to the left. You need to make sure your shading is very obvious so that it sticks out. Over exaggerate your shading, make it very wide, make sure it's obvious that you're shading in that arrowhead on whichever direction that you are going. Now, in the next section, they're giving us the graph and they want us to write the inequality that matches that graph or that the number line there. So again, do I have an open circle or a closed circle on number 2? On 2A here. Is that an open circle or a closed circle? So we have an open circle. And which way did they shade, to the left or the right? So it's shaded left. So open circle, I know I'm dealing with just greater than or less than. Which of those points to the left? Which of those inequality symbols, when the two lines come together to make the symbol, is pointing to the left? Greater than points to the right. The two numbers come together and it's pointing to the right. Less than is pointing to the left. So this would be x is less than 1. Graph B, do we have an open circle or a closed circle? Closed circle. And we can see it is shaded right. So closed circle means I'm either dealing with greater than or equal to or less than or equal to. Which of those two points to the right? Greater than or equal to. So this would be x is greater than or equal to -2. On graph C, do we have an open circle or a closed circle? Closed circle, which again tells me I'm either dealing with greater than or equal to or less than or equal to, and we can see that it is shaded left. Well, if closed circle shaded to the right was greater than or equal to, that means closed circle shaded to the left has to be less than or equal to. So x is less than or equal to 4. All right, graph D, we have an open circle and it is shaded right. So open circle means less than or greater than. It's shading to the right, so it's greater than. So we would say x is greater than -1. All right, in the next section, they're going to give us some verbal descriptions. They want us to define a variable x, write an inequality for each problem, and then check our solution. So 5 times a number is at least 35. So the at least is what we're going to pay attention to for the inequality symbol, but we need to define our variable. So we're going to say let x equal a number. So 5 times a number would be 5 times x, or 5x. So at least, which inequality symbol that we did on the previous page use the phrase at least? So yes, at least would be greater than or equal to 35. Now we're going to solve like we would if that was an equal sign. If it's multiplication, I undo multiplication with division. So x is greater than or equal. What is 35 divided by 5? 7. So we're saying x is greater than or equal to 7. Now, they did ask me to check my solution. With inequalities, we want to pick a number that satisfies, so we don't have to substitute 7 back in. I need a number that is greater than or equal to 7. So adding a little note here, when doing the check, you can pick any number that satisfies the inequality. So in our case, our inequality is x is greater than or equal to 7. So let's pick a number greater than 7 to put in for our check. So what's a number greater than 7? All right, so we can check 8. So if I check 5 times 8 to make sure that that is greater than or equal to 35, 5 times 8 is 40. That is greater than or equal to 35. That checks. It's especially important if you have just a less than symbol or a greater than symbol. You have to pick a number other than the solution number, because remember, they are not included in the answer. B, 1/3 of a number is less than or equal to. So there's our inequality phrase, less than or equal to. They went ahead and used the wording for the symbol. So again, we're going to let x equal a number. And then 1/3 of a number is telling me to do 1/3 times. So 1/3 x is less than or equal to 6. And again, we undo multiplication with division, so we divide both sides by the 1/3. So x is less than or equal to 6/1. But we also invert and multiply, so 6/1 times 3/1. So x is less than or equal to 18. Now, again, we want to check a number less than 18, but because of that fraction, we also want to make sure that number is a multiple of 3 just to make the math a little easier. Now, could you pick a number that's not a multiple of 3? Absolutely. It's just going to leave you a fraction answer instead of a whole number. So what number is, give me a number that is less than 18 but is a multiple of 3. 9. So I'm going to check 1/3 times 9 is less than or equal to 6. Well, that's 1/3 times 9/1 is less than or equal to 6. So 9/3 is less than or equal to 6. 3 is less than or equal to 6. That checks out. Part C, a number plus 3 is at most 5. So again, our inequality symbol is going to be using that phrase at most, where we're going to let x equal a number. So x plus 3 is at most. Which inequality symbol goes with at most? Less than or equal to. So x plus 3 is less than or equal to 5. So because we're adding 3, we're going to subtract. So x is less than or equal to 2. So again, in my check, I want to use a number that's less than 2 just to show that my math is correct. So what is a number that is less than 2? 1. So 1 plus 3 is less than or equal to 5. 4 is less than or equal to 5. That checks. Now, question D here can be a little confusing because it says 18 less than a number is at least 2. The inequality part of it is the at least. 18 less than a number, that goes back to module 1 for us when we were translating verbal phrases to arithmetic phrases. So again, we're going to say let x equal a number. 18 less than the number means I need to subtract 18 from that number. So x minus 18 is at least, and at least would be greater than or equal to 2. So when they say that something is less than something else, they're telling you subtraction, and the first thing is subtracted from the second. And then I'm going to add 18 to both sides. So x is greater than or equal to 20. Again, when I do my check, I want to use a number greater than 20. So what's a number greater than 20? 21. So 21 minus 18 is greater than or equal to 2. 3 is greater than or equal to 2. That does check. Now, this first set of notes we are splitting up into 2 days, so there will be homework for this set, homework for the second set. On this first set, the word problems, we're just asking you to write the equation. We are not asking you to solve. On the second part, you will have some word problems that you will have to solve. So the first one, event planning. The community center does not charge a rental fee as long as a rentee orders a minimum of $5,000 worth of food. Antonio is planning a banquet. If he is expecting 225 people to attend, what is the minimum he will have to spend on food per person to avoid paying a rental fee? Write an inequality to represent this situation, and we put there do not solve. So the key word here is minimum. So again, defining our variable, we're going to let x equal the cost per person for food. So I'm expecting 225 people, so I would have to take that 225 times that cost per person. And I need that to come out to be a minimum of 5,000 or greater than or equal to 5,000. So greater than or equal, because I need an amount that I'm charging per person so that I'm ordering at least $5,000 worth of food. All right, garbage. The amount of garbage that the average American adds to a landfill each day is 4.6 pounds. If at least 2.5 pounds of a person's daily garbage could be recycled, how much would still go into the landfill? So 4.6 pounds is the average. It could be less than that. So first, let's say let X equal unrecycled trash. So our unrecycled trash plus if we can recycle 2.5 pounds per day needs to come out to less than or equal to the 4.6 pounds. I know they use the word at least here, but that's just for the recycled, and they're actually asking us for how much that isn't recycled. So if we took our 2.5 pounds that we could recycle plus our unrecycled trash, that would need to be less than or equal to the 4.6. Again, they're just asking us to write an inequality. They are not asking us to solve. Again, tomorrow's homework, when you get that, the word problems, we will be going all the way through and solving those.